Okay, in this video, I'm going to solve a problem where the question is to analyze this circuit by completing a state diagram. Okay, so when you get a circuit analysis problem with flip-flop and combinational logic, it's always going to be that you need to find the next state table so that you can, from the next state table, you can find the state diagram. Okay, so what that means is you need to identify the state memory. So in this case, we have QA and QB, and whatever inputs that we have that drive the state memory. So I'm looking through here, and the only input I see is X. All right, so you might have the question of what order do I put things in? Well, it doesn't matter. Typically, I put the state variables as the most significant bits. It makes it a little bit easier to draw the state diagram later on, as you'll see. Okay, so from there, what I need is ultimately QA plus and QB plus, the next states. All right, and what I realize is that the next states will always follow the D inputs. Okay, so for flip-flop A, we've got DA. For flip-flop B, we've got DB. All right, so I'm looking at that, and so let's take a look at next state for QA, and it's got some logic here. And so what I'm seeing is I have an ORing of two product terms. All right, so let's write down both of the product terms. Let's do X QB bar. And how I decide what to write down is whatever it takes to help me figure out the logic. All right, so next I have QA X bar, and it's pretty easy for me to mentally OR things together. So I'm just going to go with those two columns, and I know that I can then get DA from the ORing of those two columns. All right, then I'm also going to need DB. All right, and again, that's just ORing of two columns, and so I feel comfortable ORing those together in my head, so I'm not going to write down any more than that. Okay, so from there I can find DA, which is QA plus, the next state. I wrote that backwards. Let me do it the traditional way. QA plus, which follows DA. And then I can do QB plus, which follows DB. All right. So it's helpful to put those in the same order so that you can more easily find the answer for the state diagram. Okay, so from here, I put down all the input combinations like we've done many times before. Okay, so I can find where X QB bar is a 1. So what I'm looking for is the case where X is equal to a 1 and QB is equal to 0. So here and here gives me that combination where X QB bar is equal to a 1. Okay, then I can find the next combination where I'm looking for QA X bar is equal to a 1. Okay, so QA, it would have been easier if I'd have put this in the right order. QB bar X, but you get the point. It's still 0, 1. Okay, all right. Sorry for that diversion. Let me highlight that to be consistent. All right. Just finishing this off, the rest of these would be zeros. Okay, so next, moving on to QA X bar. So I'm looking for QA equal to a 1 and X equal to a 0. So those are the only two places where that's true is here. And so I mark the 1s for those two entries. All right, and the rest of these would be 0s. All right, so from there, I know that DA, which gives me the next state for QA, is just the ORing of those two columns. That's pretty straightforward to do. And that's what we get. All right, then over here for DB. DB is just QA ORed with X. Okay, so QA is the ones are right here, and X, where X is equal to a 1, is here and here. So it's pretty easy to OR those in your head. And that completes the next state table. All right, so from there, it's just a matter of drawing the diagram. All right, so we have 0, 0, 0, 1, 1, 0, 1, 1. Okay, so when I'm in, let me change the color to blue. When I'm in 0, 0, on a 0, I go to 0, 0. When I'm in 0, 0, when I'm in 0, 0, on a 1, I go to 1, 1. I'm just going to leave that as blue. Okay, on a 0, 1, when I get a 0, I go to 0, 0. On 0, 1, when I get a 1, I go to 0, 1. When I'm in 1, 0 on a 0, I go to 1, 1. When I'm in 1, 0 on a 1, I go to 1, 1. So both of these take me to that same state. When I'm in 1, 1 on a 0, I go to 1, 1. And finally, when I'm in 1, 1 on a 1, I go to 0, 1. All right, so that completes the analysis of this circuit, and that's the technique that you use. So hopefully you know immediately what to do. You see a flip-flop analysis type of problem. You then construct the next state table. So you break down the logic that you need in order to accurately construct that table. From there, it's just a matter of going through the table and figuring out the next state logic. All right, so it's a little easier to do that if you put QA and QB together, followed by the input, and that way you can tell what happens at each state. So in other words, you start at 0, 0, and you look at both conditions and figure out where the next states would be. All right, so that's how you do that kind of problem, and hopefully you'll never have trouble with that kind again.